Let's take a look at some applications of parabolas. Here's the first problem. Please pause the video, write it down, and then I'll walk you through it. Here we go. You got a tractor company, and revenue, R, revenue based on some P price in dollars, is given by this function. They want us to determine the price that the company should charge to maximize revenue. Well, first, we know we have a parabola. The leading coefficient is negative, so therefore our parabola faces down. With it facing down, the ordered pair of the vertex is price and revenue. P for price here, revenue of the function here. The y value is they want you to maximize the revenue. So you're going to maximize the largest y you can get occurs here at that parabola vertex. Let's use what we know about parabolas. We can use negative b over 2a to get the x value of the vertex. So let's first write a equals negative 1/2. B equals 1900. We're just pulling coefficients off of that quadratic here, A, B. And the vertex, the x-coordinate, is negative b over 2a, so negative 1900 over 2 times negative 1/2. And when you simplify that, you get, right, new color, 2's divide out to give you 1, so you get negative 1900 over negative 1, so you get positive 1900. You have now found the price that they need to charge in order to maximize revenue, and you can even start your answer. They should charge $1,900 to earn max revenue of, and we need to go find that. And so we have the x-coordinate of the vertex, now we need the y-coordinate. To find that, we take that 1900, substitute it into our function, negative 1/2 times 1900 squared, plus 1900 from the function, and substitute the p in, which is 1900. And when you put that in, use your calculator, and that will give you $1,805,000. And so their maximum profit, $1,805,000, is going to be had when they charge $1,900 for each tractor. Here's another one, the marginal cost. For this one, I'd like you to pause the video and write the problem down and then come back. Welcome back. So for this problem, the leading coefficient, 5, here is positive. What that means is your parabola is facing up. The vertex is sitting here. Does this make sense with this problem? They want to know how many cell phones should be manufactured to minimize the marginal cost. Well, X is the number of cell phones being manufactured, and the marginal cost is that Y value here, C of X. That is a minimum here, so that makes sense that here we find that minimum value. So if that was part of your difficulty, pause the video again and then keep moving. See if you can find that number of cell phones and what that marginal cost is that they've been able to minimize. We're going to do exactly what we did before. We're going to pull the A and the B off of our quadratic. So A equals 5, B equals negative 200. We're going to use negative b over 2a. That's the x-coordinate of the vertex. So that gives us negative 200 gives you positive 200 over 2 times 5. That's 10. 200 divided by 10 is 20. Now we want to find the y-coordinate of that vertex. To do that, we're going to substitute the 20 into the original function. 5 times 20 squared minus 200 times 20 plus 4,000. And use your calculator, and you'll find that that's 2,000. And what this tells us is that the vertex is 22,000. With respect to our problem, this is the number of phones, and this is the marginal cost that's been minimized. Remember, we've got our parabola facing like this, and you just found this vertex. And so what should they do for manufacturing? They should manufacture, and it's the 20 for the cell phone here is in thousands, so it's 20,000 phones to minimize their marginal cost. Minimize. Their marginal cost. And their marginal cost is going to be 2,000. And that's it. So you just have to be paying attention to whether your parabolas are facing up or down, whether you're minimizing or maximizing. Don't get caught in the loop of, oh, we just do negative b over 2a and here we go. Well, you really do need to know whether you have a parabola facing up or facing down, and whether you are minimizing or maximizing. What are the units of each of these? So just keep your eyes open. I do recommend that you do practice some. There's only 3 here. Put them in your notes and bring them with you. Have a great day.